Scientists have made an incredible and groundbreaking discovery at the very center of these mysterious cosmic entities known as black holes. In a remarkable turn of events, researchers have unearthed something both amazing and terrifying inside a black hole, something that is now challenging everything we thought we understood about these enigmatic wonders of the cosmos. For many years, black holes have been regarded as untouchable and elusive, only grasped through mathematical theory and distant observations. However, this new revelation has transformed our understanding, casting a new light on the forces that govern the universe. If you're interested in learning more about the latest discoveries from the universe and staying updated on cosmic news, consider subscribing to our channel. Be sure to like this video, share it with others so it reaches a wider audience, and turn on the notification bell to stay informed about future updates and discoveries. Black holes have always fascinated scientists and space enthusiasts alike. These cosmic phenomena were first predicted by Albert Einstein, one of the most brilliant scientific minds in history, through his theory of general relativity. This revolutionary theory transformed our understanding of how the universe works. According to Einstein's theory, black holes are places in space where gravity is so intense that not even light, the fastest entity in the universe, can escape. This gravity doesn't behave in the conventional way that we typically think of, like the forces of magnetism or push and pull. Instead, it arises from the curvature of space and time, two fundamental elements that make up the fabric of the universe. Gravity, according to this theory, results from how objects with mass and energy warp or bend space-time. The more mass an object has, the more it bends space-time around it, causing what we perceive as gravitational force. When applied to black holes, this concept becomes even more extreme, as black holes possess such enormous mass and energy that they distort space and time to an extraordinary degree. To better understand black holes, it's crucial to grasp just how extreme these objects are. Unlike anything else in the universe, black holes contain an unfathomable amount of mass and energy concentrated into a very tiny space. This immense concentration of matter creates a gravitational field so intense that it warps the very fabric of space-time around it, creating what we call a gravitational well. This well, or warp, becomes deeper and deeper as more mass and energy are concentrated in the black hole. As the gravitational pull strengthens, it creates a boundary known as the event horizon. This boundary is not a physical wall or barrier that you can touch or see, but rather a region where space is so heavily bent by the black hole's gravitational pull that once something crosses this point, it can never escape. Even light, which travels at an astonishing speed of 300,000 kilometers per second, is trapped if it ventures too close. The event horizon marks the point of no return, where the escape velocity required to leave the black hole exceeds the speed of light, a speed we know to be impossible to achieve according to the laws of physics. At this point, the phenomena surrounding black holes become even more extraordinary. The event horizon is not just a gateway to oblivion. It also marks a region of space where the laws of physics as we know them start to break down. This is why scientists are so fascinated by black holes. They represent the most extreme conditions in the universe. At the center of a black hole lies what is known as the singularity. The singularity is a place where all the black hole's mass and energy are compressed into an infinitely small point. This dense point has infinite curvature and gravitational force, making it impossible for us to apply our current understanding of physics. In the singularity, space and time themselves collapse and are stop making sense. The intense gravitational forces warp space-time so dramatically that the familiar laws of nature seem to disappear. This has led scientists to speculate and theorize about the true nature of the singularity. Does it hold the key to new physics? Could it offer clues to a unified theory that explains both gravity and quantum mechanics? These questions remain unanswered, as the singularity represents the ultimate unknown. To understand how black holes form, we need to examine the life cycle of massive stars, the cosmic powerhouses that eventually give birth to these mysterious objects. Massive stars are fueled by nuclear fusion reactions in their cores. These reactions, which involve the fusion of hydrogen atoms into helium, release an immense amount of energy. This energy creates an outward pressure that counteracts the star's gravity, allowing the star to maintain its structure and brightness. As long as the star has enough hydrogen to fuel the fusion process, it will continue to shine. However, stars are voracious consumers of hydrogen, and as they age, they begin to run out of this essential fuel. When the hydrogen supply is depleted, the star begins to fuse heavier elements like helium, carbon, and oxygen. Each time a heavier element is fused, less energy is produced, and the star must burn hotter and faster to maintain its balance. This process continues until the star can no longer fuse elements to produce energy. At this critical moment, the star collapses under its own immense gravitational pull, creating a spectacular implosion. In this dramatic event, a black hole is born, with the core of the collapsed star forming the singularity at its center. In an unprecedented achievement, scientists have pointed their state-of-the-art telescopes into the interior of a supermassive black hole located at the center of a galaxy 800 million light-years away. Black holes are notorious for their insatiable hunger, devouring anything that gets too close, whether it's matter, gas, or even light itself. This particular black hole's latest cosmic feast was extraordinary. As matter was pulled into the black hole, it was heated to extreme temperatures, reaching millions of degrees. This superheated matter formed a glowing ring of gas, known as a corona, around the black hole. The result was a dazzling display of cosmic fireworks, with powerful X-ray flares emanating from the black hole's corona. But these flares didn't simply disappear into the black hole's abyss. Instead, they experienced a remarkable phenomenon. They were reflected back from the gas behind the black hole in a cosmic bounce, defying the conventional laws of physics. These flares survived the black hole's immense gravitational and magnetic forces. The black hole's extreme gravity bent the X-ray flares' paths, curving them in such a way that they eventually reached Earth's telescopes. This discovery represents a groundbreaking moment in astrophysics. For the first time, light from inside a black hole has been observed. This confirmation of Einstein's theory of general relativity is monumental, as his work predicted that light could be bent by gravity. This phenomenon, observed and confirmed through these flares, has provided another stunning validation of Einstein's ideas. But how did scientists make this discovery? The story revolves around two incredible space telescopes, the XMM Newton, operated by the European Space Agency, and NASA's James Webb Space Telescope. These powerful observatories focused on the supermassive black hole for several days, watching as X-ray flares danced around it. However, upon closer examination of the data, researchers noticed something strange. Some of the flares had different colors and arrived later than others. This observation raised new questions. Why were these flares delayed? What caused the change in color? Through careful analysis, scientists discovered that these X-ray signals came from inside the black hole itself. This surprising result led to the identification of a phenomenon called a light echo. Black holes, as we know, possess gravity so strong that not even light can escape once it crosses the event horizon. However, near the event horizon, there is often a disk of material, such as gas and dust, that is being pulled toward the black hole. As this material spirals closer, it heats up, emitting X-rays and other radiation, creating a bright, luminous halo called a corona. The material around the black hole interacts with its powerful gravitational field in fascinating ways, causing the light to echo around the black hole before eventually reaching us. What do you think of these extraordinary discoveries? Let us know in the comments below. If you enjoyed this video and want to stay informed about the latest developments in space exploration and astrophysics, don't forget to hit the like button and subscribe to our channel. That way, you won't miss any of our future videos on the wonders of the universe. Thank you for watching, and we'll see you next time.